I'm Stephen Hardy, Editorial Director of Broadband Technology Report, and welcome to this third session of the second day of the 2023 BTR Summit. This 30-minute session will review the major points behind improving customer experience through network automation. We at BTR, of course, thank all of our summit sponsors, but in particular, we'd like to thank Technetix for making this session possible. So whether it's distributed access architectures, advanced DOCSIS 3.1, or an evolution towards DOCSIS 4.0, almost every cable operator is either about to start or is in the midst of some sort of network upgrade program. But new complexities can arise alongside new capabilities, and that's where the application of automation can help increase both the efficiency of architecture enhancements as well as network operations. To look at both how automation can benefit network operations as well as strategies to implement such automation, it's my pleasure to be joined for a conversation by Nader Foroughi, Chief Technology Officer Americas at Technetix. Nader's held this role since June of last year, coming to Technetix from Shaw Communications, where he was a principal architect. Much of Nader's career has been spent working in research and development, primarily focused on the evolution of broadband access systems and data analytics. He's a tenured industry panelist and speaker at the SCTE and CableLabs conferences. Nader also has published numerous white papers and has been a primary contributor to several recent industry developments, including DOCSIS 4.0, distributed gain architecture, and the Technetix One-Touch Network. So I have a few questions prepared for Nader, but we want you to be able to ask him questions as well, and you can do that by using the Q&A submission window, which you should see nearest on your screen. To submit a question, just click in the box, type in a question, and hit the submission button. Also, in the event you run into a technical problem during this session, you can call for help using that Q&A tool as well. Just describe your problem, hit the question submission button, and Savannah, our session technician, will be happy to help you out. And with that, let's begin. Nader, what do you see as the main benefits of HFC network automation, particularly in comparison to traditional manual methods?
Very good question, Stephen. Well, first of all, thank you for hosting us, and thank you to everyone who's dialed in listening to this panel. It should be a good one. So to answer your question, network automation in general, I guess the biggest benefit that it could provide over the traditional manual approaches that we've had could be summarized in, I guess, two things. One of it would be unwanted operational cost optimization and mitigating those unwanted operational costs, both short-term and long-term. And the other one is better decision-making in general. So like you mentioned, every operator around the world has made major announcements on changes coming to their access network and revolutionizing it towards whatever that next step might be for them. From high split to DOCSIS 4.0, maybe full duplex DOCSIS or extended spectrum DOCSIS. As a part of these upgrades, I think lies an immense opportunity to truly revolutionize the way we look at access network in general. And as a part of that comes all of the operational expenses that are associated with it. You look at a typical HFC plant out there and the amount of activities that it entails, not just from an upgrade perspective, but ongoing maintenance perspective as an example. From retuning amplifiers to upstream and downstream alignment to adding channel lineups to different serving groups based on their unique characteristics, or turning up OFDM carriers as a part of DOCSIS 3.1 or DOCSIS 4 upgrades in general. All of those currently are done based on manual analyses and manual provisioning, maintenance, all of the activities that we've been talking about. But as a part of these upgrades, we could truly revolutionize this whole process by utilizing automation to make all of those difficult decisions for us, because a lot of these repetitive tasks and heavy mathematical tasks that we rely on doing the process manually can be fully automated as of today. There are some aspects of it that would also be beneficial for everyone to consider. Power reduction would be a really good one to talk about. Power has been a primary focus for a lot of operators. Rightfully so. That's one of the biggest operational expenses that everyone has to overcome in the foreseeable future, given all the recent announcements that we've seen from operators around the world. And that's another aspect of it that we think, using artificial intelligence and machine learning, we can substantially reduce the amount of power draw from the field. And that's been a heavy focus for us at Technetix over the last year. both on the automation side of things from a plant maintenance perspective and what that could entail going into the future with changing splits and all the revolutionizing that comes with upgrading an access network, and power. So all the components that we're looking to bring into the field and into the market for that matter will enable these functionalities to be embedded in the access equipment in general.
So you were just mentioning some field operations. How do you see network automation affecting the role of technicians and field staff?
That's a very good question. So we had a discussion yesterday on the topic as well, and I think the messaging around this is quite important because there's sometimes a misconception that artificial intelligence and automation is looking to replace everything. Although there are applications out there that artificial intelligence can be utilized to replace a lot of the repetitive tasks that any staff could be taking, could be engineers to designers to plant technicians or frontline staff for that matter. But in short, I believe that it actually enhances the decisions that they would have had to make without the use of data historically. I think it enhances the not only the decisions that they're making, but also just the day-to-day jobs that they have to I guess take on a daily basis. So you look at the plant's maintenance is an easy one to talk about, from upstream downstream alignment like we were talking originally, or having to realign a cascade of networks if something changes in the field. Technicians have to go out and redo all of these work, and I don't particularly think that any technician likes to realign amplifiers at 3 a.m. Especially if it's colder outside, right? So a lot of these I guess difficult tasks that we've had to rely on historically to be done manually, most of those can be mitigated by using artificial intelligence because the algorithms are able to do all of the work that we're able to do today. They can replace them today. But then that will free them up to tackle some of the most difficult parts of the HFC network, or any network for that matter, like chasing ingress noise or any of those complicated tasks that we would have to rely on technicians to do the work rather than relying on a machine to do it.
So you've mentioned some of the benefits of network automation. What are some of the challenges to implementing network automation, and how can they be overcome?
Well, the list of that is a little bit long, so I'll try to summarize it to the best of my ability. I can probably talk about this one topic for an hour. The cultural shift is a big one that comes to mind initially, and the messaging both on the vendor community and the operator, I guess the MSO community in general. Looking at utilizing automation to mitigate a lot of these unwanted costs, short-term and long-term, could be a huge benefit to our industry as a whole. So I think embracing automation and artificial intelligence, knowing the computational power that we have today, the access that we have to a plethora of good data that historically we didn't have access to, that is a very big part of it. But also one of the areas that we've been focusing on heavily at Technetix is bringing components that enable those automation pieces to be embedded in the equipment. Today, a lot of the access equipment doesn't have any intelligence embedded in it. And when you look at, hypothetically speaking, if the equipment that we're bringing to the market was able to have not only reporting capability to be able to get telemetry data from it and performance reporting from the equipment, but also be able to configure them remotely. And as a matter of fact, build towards an end goal of being able to feed these algorithms and methodologies into an artificial intelligence type of platform that would make all of those decisions for you. That frees up so much resources. And like I said, if you were to list the pros and cons of both sides, the list of pros are truly limitless. So I highly encourage everyone to do these type of studies for themselves, and I'm certain that you'll come to the same conclusion.
All right. So one question that's kind of on the forefront of discussion in terms of network upgrades is rolling out fiber networks and or upgrading HFC infrastructure. What do you see as being kind of the the costs between the two of those, and what are some of the factors that cable companies should consider when it comes to evaluating potential costs of either approach?
So fiber to the prem, or FTTH, has been, like we've seen, a huge uptake in the world as far as deployment is concerned. But the biggest advantage that we have in an HFC system is the fact that coax not only passes all of the upper cutoff frequency of a coaxial network is much higher than what we've tapped into today. It also passes power. So the number of advantages that we have on an HFC network is very, very good. I guess one of the biggest areas of focus for operators lately has been operational costs, to be able to mitigate them long-term, unwanted operational costs, that is. And one of the perceived advantages of fiber to the prem is that it's a passive network. So you spend the capex upfront and you build the network, you upgrade it, but you wouldn't have to go back and revisit the same locations over and over again to be able to upgrade any equipment in between the two endpoints, being say an OLT and a cable modem receiving the signal, right? And that's actually one of the areas that we've been focusing on quite heavily, is to look at the network as a black box, essentially, as a transparent pipe that you transfer your signals through. The signal could be coming from an OLT, it could be coming from a CMTS, it could be, in certain instances, in some areas, it could be both, depending on what the future iteration of remote PHY architectures and devices could look like. And that's the point that we've been trying to drive in, both internally and externally, is to look at the network as the access network as a transparent pipe. As a part of that, there's a lot of opportunities to even further enhance the functionality of an HFC system. Like we were mentioning, the biggest advantage, or one of the biggest advantage of it, is that, first of all, the upper frequency cutoff is very high on a coaxial network. On a drop, on an RG6 drop, you could have up to 15 or 20 gigahertz worth of spectrum, which, I mean, you do the calculations of what type of capacity that unleashes, but also it passes power. But if we could get to a place that you wouldn't have to revisit these locations over and over again, the HFC system, we've been operating it for the last few decades, and I believe that it's going to stick around for much longer. So just essentially having to mitigate the fact that you have to revisit the same locations, using automation and power reduction methods to even further enhance the functionalities of an HFC system.
So you've mentioned several benefits for the network operators. Are there benefits to the customers from network automation as well? And if so, how do you measure these benefits in terms of improvements to customer experience?
It's a very good question. So when you look at performance in the real world, historically, we would have had to make a lot of decisions without the use of data. So a lot of the design decisions and measurements that we have in place are not true measures of performance. They're proxy measures of performance. As an example, you look at the way an HFC system has been designed historically. Because of the lack of, I guess, reporting capability in cable modems historically, we typically would design for the cascade. We would design for the amplifiers and the nodes, and you would pick a reasonable worst case scenario or a worst case scenario to design for, and then your assumption is that everything falls in place for the cable modem to receive whatever it's receiving. And for operators, I actually highly encourage you to do a poll of all of your modems in the field and see the wide range of receive levels that you have in the field. And that tells you that sometimes the paper exercises don't translate directly into what the performance could be in the real world. Another really good example of it is that as network engineers, we've been highly focused on performance of amplifiers and actives, and signal to noise ratio and carrier to intermod ratio, and all the stuff that comes with designing an active system, being the HFC system. But we sometimes don't really look at the end performance of the device, because you look at a cable modem as an example. The biggest metrics that matter, or attributes that matter to the cable modem, is speed, latency, and jitter. Those are the things that are typically measured by the end user. Those are the measures that we've been using for any network connectivity in general. And those are the attributes that I think we should strive to get towards, to essentially get into a place that we have a true measure of performance rather than using a proxy for measurements, which kind of ties back into what I was saying, looking at the access network as a transparent pipe rather than measuring it specifically for the components that we're deploying. And uptime is another really important one that comes to mind. Uptime is one of the most important attributes and key measures that consumers are looking for today. I don't think it's a secret when you look at all of the polls that have been done recently. Plant reliability and stability comes up on the top three most looked for attributes in an operator when someone's trying to sign up for an internet provider in general. And that's one of the areas that I think automation can provide an immense amount of benefit to increase your uptime substantially without having to take down the plant to realign things, or as a matter of fact, be able to configure all of these devices remotely. Like I said, the number of benefits that come to mind are truly limitless.
So I'll take this moment to note that we're a bit over halfway through this session, and we continue to be interested in fielding any questions you folks in the audience may have. If you've got a question for Nader, all you have to do is click in the Ask a Question box, type in the question, and hit the submission button. So one thing we hear a lot about in the context of automation is data-driven decisions and data analytics. What role do you see such data analytics and potentially, such current buzzwords as machine learning playing in network automation? And how do you see companies actually leveraging some of these buzzwords in
that's a good one.
in their operations?
I'll try to not make my answer as buzzwordy as I can, if that makes sense. So machine learning is a key part of automation. As a matter of fact, it's probably the core engine that enables a lot of these functionalities. But at the same time, we don't want this to come across as an incredibly complicated or very difficult thing to get off the ground. Data-driven analytics and just data-driven decision-making is a concept that's been around since pretty much the dawn of probability and statistics, mathematically speaking. As a matter of fact, if you look at machine learning, it's really nothing more than probability and statistics mixed with programming languages. And of course, you can get this towards a place that you have deep learning methods with neural networks and unsupervised machine learning techniques and everything like that. But it really doesn't have to be that complicated. A lot of the projects that we've been working on lately and in my previous career, it just relies on being able to pull large sums of data, process them in a meaningful way, and be able to extract attributes and measures that are statistically relevant to your end objective. That itself is a very good start for any operator or vendor for that matter. One of the areas that we've been focusing on Technetix is to take that foundation and take it a few steps further as far as what type of true automation, methodologies we can apply to data-driven analytics in general to truly remove some of the complexities, because in the real world, like we're talking about, a lot of the measurements that we have today are unidimensional, where in reality, in the real world, everything is a multi-objective optimization type of technique, and that is very difficult for a human to do, whereas machines, they're dimensionless. You can have 5 or 6 different dimensions for any optimization technique. So those are the areas that I think anyone can immediately start benefiting from. Just start from data analytics and build towards machine learning and artificial intelligence.
Very good. So one thing that operators are always interested in is reducing truck rolls as well as other field service costs. How do you see network automation helping in this goal?
Well, where do I begin? I guess there's a few areas that immediately come to mind. As a part of network upgrades in general, one of the biggest key messages that we've heard in the industry is that you want to avoid having to revisit the same locations over and over again, because that is by far one of the biggest, if not the most expensive part of the network operation in general. And then with that comes ongoing maintenance activities. At the end of the day, HFC is a living, breathing, active type of system that has to be continually maintained. And changing future splits is another good example. You have to go, say, as an example, if you wanted to go from high split to ultra high split or whatever that variation might be, all of these activities can be replaced and mitigated by using artificial intelligence and automation today. So we are hoping to get to a place that the efficiency of truck rolls and the efficiency of targeted truck rolls, for that matter, we can get it to a place that it's as accurate as it can be, rather than having to play whack-a-mole with ingress noise. And ingress noise is a good one to pick on because it's just an easy target these days. But like I said, I don't think anyone's particularly thrilled about having to chase ingress noise around, going from one amplifier to another. Whereas today, with the methodologies that we're bringing into the market, we can mitigate them almost immediately using automation.
So speaking of efficient truck rolls, what role, if any, do you see network automation playing in the ability of operators to rapidly respond to network outages and other kinds of major service interruptions?
So one of the, I guess, the key areas that has been an area of focus for the industry is automatic provisioning and automatic monitoring. So you look at the amount of data that is required by someone to make a decision on, as an example, where an outage particularly started, even better, where it could be starting before it's even happened, given the characteristics of the plant and the signals that it can provide to a back-end system. A lot of, I guess, current methods of data collection can be fed into an engine where a lot of these, not only the predictions, but also pinpointing exactly where the problem is coming from, is a very viable option. And like I said, this is nothing too complicated that you have to have like a deep neural network of a sort to be able to determine these things. With basic machine learning methods today, we can pinpoint exactly where these problems are coming from. And on top of that, you look at, after an outage, going back to what we were talking about, or outages in general, uptime is one of the most important things these days. Internet is essentially a utility for everyone, with the way the world is going in general. So automation not only can mitigate some of these instances and reduce the amount of errors that we've seen in the past with channel lineup changes or provisioning changes or anything like that. It also can just bring the plants back up much, much faster if something were to happen as far as a physical change. Like if a cable cut happens, automation might not be able to help you with changing that. It doesn't today, unless there's like a field of robotics or something like that I'm not aware of. But as far as provisioning and making sure that everything is back up to where it used to be and where it should be, that's where automation can play a very big role.
Very good. So I wanted to ask you next about the future of automation, but it turns out somebody in our audience would like you to discuss that as well. So perhaps I'll turn to the audience question as a springboard for this. The audience member wants to know what your feelings are about the application of AI in these kinds of network automation exercises, and would AI actually even speed up the response time of some of these network automation initiatives?
Absolutely. Absolutely. In short, it absolutely does, yes. From a very basic point of view, being able to pinpoint exactly where the problem is coming from is by far one of the most important applications of artificial intelligence and machine learning today. And this is not a revolutionary concept. There's a lot of fantastic work that's already been done by P&M working groups and SCTE CableLabs working groups already. What we've been able to do is to take that foundation and take it a few steps further, like I was mentioning. The components in the field, assuming that they can enable AI, ML, and just automation in general as an umbrella. Not only you can pinpoint a lot of these problems, a lot, if not most of the problems that you see in the field can be remotely mitigated. The concept of self-healing networks have been talked about for a while in the industry, and I think we can get to a place that we can absolutely get there.
All right. And in addition to the application of AI, do you see other future trends that we haven't touched on yet?
Mhm. Well, that's where we spend a lot of our times in the CTO office of Technetix, thinking about where the industry can and will go. And we touched on it briefly during some of the previous discussion. With artificial intelligence and machine learning, there's a lot of, I guess, entry-level things that we can immediately take advantage of as far as just data analytics and data-driven decision-making and design and planning and maintenance and everything that comes with it. I do think that we can get this to a place that a lot, if not most, of the decisions that we make today, a lot of the manual processes that we have today, the repetitive tasks that we have today, these can be, we can take them to a place that can essentially be replaced by artificial intelligence, because turning off channels is a very good example of this. Each plant segment has its own unique characteristics, and we know this. But historically, because we didn't have the data to work with, we typically try to put the design in some sort of a box that says, like, if it's within these boundaries, you do this. If it's within these boundaries, you do that. But in the real world, anything and everything does happen. So that is, I think, one of the biggest areas of focus for us, to embrace the uncertainty of the real world, knowing that you can't predict exactly when and if something is going to happen, but if it does, how can you respond to it? That is the end goal that we're trying to drive towards.
Mm-hmm. So let's see, we've got time maybe for one more question. Actually, I'm going to pull out a question that we didn't quite get to in our panel yesterday. I'm interested, though, in your thoughts about it. One thing that is often described as very important in terms of being able to enable end-to-end network automation is interdepartmental collaboration. How can operators promote this kind of collaboration?
So when you look at system design or systems architecture in general, that's one of the areas that truly embraces interconnectivity of different departments. Historically, we've had to rely on a lot of, say, siloed type of decisions that, one department makes a series of decisions and then passes it on to another department, and so on and so forth. A good example of that in our industry would be the interconnectivity and intercomplexities that we see between design, engineering, and operations. And then you tie this back into backend OSS, BSS systems as well. Every decision from each of the previously mentioned departments creates a ripple effect across the board for all the other departments that are involved. And evaluating these complexities is a very mathematically intense problem, to the point that even if you're the best at solving integral differential equations, it's very difficult to characterize what that exactly looks like. But with machine learning methods, multi-objective optimization techniques, and all the current methods that have been used in many other industries, we can start looking at a true end-to-end system design. And I do think that that is crucial to the future of our industry, particularly when you look at DAA and how it's really becoming difficult to put a boundary between where each team's responsibility starts and finishes. So we will get there. We just have to make sure that we're a few steps ahead of the curve.
Very good. Thank you, Nader. And that concludes our session, but I have one more question to ask, and that's for you people in the audience. Please let us know what you think of this panel via the poll question we're about to pop out to you right now. While you're answering that poll, I'd like to thank Nader once again for sharing his expertise, Technetix for making this session possible, and of course, you and our audience for watching. Next, we wrap up our day and our event with a webinar from SCTE that will start in just a few minutes. Hope you'll join me in switching over to that session. If not, have a great rest of your day and goodbye.
Awesome. Thank you.